Ladies and gentlemen, the day before the election. Whew, guys, I'm pretty nervous. Not gonna lie, I'm pretty nervous, but you know, the sun will still rise on Wednesday morning, so it'll be okay. Whatever happens, it'll be okay. All right. Today's lesson is a continuation of Wednesday's lesson about dichotomous keys. So hopefully you took a bit of time to look at those cool organisms on dichotomous keys. I'd like to go over the organisms with you right now. Okay, as you can see, we are on page 27 of your bills, and I'm gonna have a brain jog for you, brain jog number 2, and that'll go on page 26. I'm going to stop that share and I'm going to go over, whoops, wrong one. Go over the agenda for today. Here we go. So brain jog number 2 is on dichotomous keys. That goes on page 26. We're going to do an explanation right now. You guys will make for me a dichotomous key, and it could be about anything that's school appropriate. So it could be a dichotomous key about anime characters. It could be a dichotomous key about Pokemon, could be about all other things teenagers are into these days, as long as it's school appropriate, okay? Finally, I'm going to assign something called a stump speech. So from this point forward after this lesson, we are going to expand our exploration of organisms on the planet. I'm going to have you guys select, since there are 16 of you, there are 16 different types of organisms that we want to investigate. And at the very end, I'm going to go over the stump speech rubric so we have an idea about what you're supposed to do. Now, when are these speeches supposed to be done and filmed? I would like them done and filmed in the next couple of days. It's really easy. It's really easy. You just get on camera and you say, hey, blah, blah, blah. I'll talk more about that at the very end. So those are your stump speeches. And I know it's at the same time as your practical and it's quite stressful, but keep in mind that the practical was supposed to be due last week. So, okay. With that in mind, we're going to leave that to the very end. Today, we're going to focus again on those dichotomous keys. You were supposed to do a lab activity where you looked through a microscope and you looked at the microorganisms that we can add into our Pokédex. I'd like to go over them today, so I'm going to stop that share, and I'm going to go back to our notes here. And once again, the completed version looks something like this. We're going to go over all, what was it? 12 different microscopic organisms. All right. Number 1 was an organism called planaria. I'll take your flashcards out and also your markers. We're going to need them both. The first microorganism is called planaria. Okay. Planaria, I'm going to draw, looks a little something like this, like a little arrow. Planaria has these 2 little eyes right here. What I would like you to do is I'd like you to add all of the organisms I'm going to draw here into your Pokédex. There are more microorganisms than there are macroorganisms. So in our discussion of biodiversity, it's really important that we talk about things we can't see with our own eyes. I know some of you are probably more interested in the organisms you can see with your eyes, like spiders, crabs, tigers, jaguars, but all of the microorganisms are super neat as well. One being a planaria, kingdom Animalia. The second organism is something that we're all familiar with. These are squamous epithelial cells. Squamous epithelial cells. And these are your cheek cells. Obviously, they're cells from your cheek, but the correct classification are squamous epithelial cells. Squamous is referring to the shape. It doesn't really have a regular shape, so we call it squamous. Epithelial meaning the outer layer, cells. There you go. And this almost goes without saying, because we extract them from our cheeks, they are from kingdom Animalia. The third type of microorganism that you were supposed to see in the microscopes is called Rhizophus. Now the Rhizophus cells this was probably the most challenging to identify because they're kind of crisscrossed cells like this. You got like a little bulb right here, but then there's like a cell coming down here with another little bulb, and it's really difficult to see. Within each of these rods, you have these little dots. These little dots are nuclei. So we can see very clearly that the cells are multinucleated. And there's really only one kingdom that has multinucleated cells. I would usually wait for you to answer the question. Kingdom fungi. A mushroom walks up to a house that's having a party, knocks on the door, and says, "Hey, you guys having a party?" The person who opened the door slammed it in his face and he said, "Hey, wait a second. I'm a pretty fun guy." Said to nobody. Okay. The fourth microorganism is a really cool one. You guys have probably heard about this thinking about Greek mythology. This is called a hydra. Now, if you've seen the animated film Hercules, you know that in Greek mythology, the hydra is this dragon-like monster that if you cut off one of its head, two grows in its place. Well, the microorganism, the real one, is an organism with a bunch of appendages at the very end that they can grow back. They don't multiply, but they can grow back. The nucleus right here. And the hydra belongs to kingdom Animalia. I don't know if I've ringed the bell for all these, but one for squamous epithelial cell, one for Rhizophus, and one for hydra. Number 5 is an organism called Paramecium. Paramecium we've actually talked about before, way, way, way back in the day. Paramecium looks like a little football, a green football. And we talked about this when I introduced Protista a long, long time ago. Kingdom Protista. Paramecium has something called a contractile vacuole. Do you remember? They also have a food vacuole as well. Paramecium are like single-celled animals. They're pretty cool. The other protista that I like to introduce to you is something called a amoeba. Amoeba. The amoeba looks a little bit like an alien. It's got like these appendages out here that can suck things up. It's like a little octopus, a microorganism. The amoeba can actually eat the paramecium, so the amoeba is a heterotroph. It's pretty cool. The way it eats is that these feet kind of survey the surrounding environment, and if it sees something edible, the foot will stick to whatever is edible, and then it will absorb that thing that it wants to eat. These feet are called fake feet, pseudopods. So pseudo means fake, pods means appendages, pseudopods. One of my favorites, number 7. Oh, wait, ring for amoeba. One of my favorites is called oscillatoria. Oscillatoria is actually one long single cell, but it's broken into different segments like this. It looks like a little ruler. Cute. It's funny to think that all these organisms are living, just like you and me. Maybe they have their form of Netflix also. Oscillatoria doesn't look like it, but it's actually part of kingdom Monera. It's a bacteria. I know, you don't usually see bacteria that look like that. So it's pretty cool. Number 8 is called Volvox. Volvox, I think, is my favorite because it glows. I'm not sure if it glows in the dark, but it definitely does glow. Volvox is like a big cell with little tiny. It looks a little bit like a chocolate chip cookie with hairs on it. Except the chocolate chip cookies are not brown. These chips, quote unquote, are luminescent. That means it glows. I think Volvoxes are really neat. I remember being introduced to Volvox once upon a time in high school, and I was like, whoa, man, this is so cool. And I wasn't being sarcastic either. I actually did think it was cool. I still do. Volvox. Okay, 3 more. The 9th one, I believe in your handout, I gave it to you as Trichomonas hominis. Now, Trichomonas hominis is one of these fresh water organisms. So if you go into like a river or a lake and you take a big gulp of that water, you could be gulping Trichomonas hominis. Okay, if you do, you might end up with a condition known as trichomoniasis. Trichomoniasis is inflammation of your body as a result of consuming this organism. This root tri is referring to the organism's 3 tails. 1, 2, 3. Kind of like a tricycle. Instead of a bicycle, it's a tricycle. So this organism has 3 tails to it. And if consumed, it can really, really hurt you. I think it messes up your kidney system or something. I forget the symptoms exactly. Trichomonas hominis is belonging to kingdom Monera. That's why if I ever go to a lake, I never want to swim in the lake. No way, a lake, a river, pfft, forget about it. So many things are living in there. Even going to the beach kind of freaks me out because if you're in the water and you take a big gulp of it, imagine all the living things that you're actually drinking. Ooh. I do enjoy the beach though, not to say anything bad about the beach. Okay, number 10 is a leaf cell. Well, the cells of a leaf. And the way it's displayed for you in the lab is on its side. So we're going to call this a herbaceous leaf. And it looks a little something like this. So it kind of looks like a cake. You have a top layer, then you have a bottom layer down here, but the bottom layer has cells that are kind of split up like this. So it's kind of a two-layered cake, kind of a tres leche kind of cake. Dos leche. And up here you have cells that are way more dense. Concentrated is another way to think about it as well. So on the top layer are cells that are way more photosynthetic. So this would be the top of the leaf, and in here would be the bottom of the leaf. And these cells down here, since they're at the bottom, they don't get as much sunlight. So what do? They're responsible more for gas exchange. Kingdom? Kingdom Plantae. And finally, the last microorganism we're going to look at is called Spirogyra. Did anyone play the game Spyro growing up? Spyro the Purple Dragon? I always think of Spyro. Or the politician Spyro Agnew. Spyro Agnew was President Richard Nixon's vice president. Anyway, Spirogyra looks like a little slinky. It spirals. Spirogyra belongs to kingdom Protista. You can look up these organisms online, which was assigned to you. These are the microorganisms that I'm going to hold you responsible for identifying. Summary: planaria, animal cells, rhizophus, hydra, paramecium, amoeba, oscillatoria, volvox, trichomonas hominis, herbaceous leaf, and Spirogyra. Not only do you have to recognize them by looking at a picture, but you also have to know what kingdom they belong to. Most of them are pretty intuitive. Cheek cells, Animalia. Herbaceous leaf, Plantae. Some of them are a little trickier, so be careful. Trichomonas hominis, Monera. Oscillatoria, Monera. Spirogyra, amoeba, paramecium, protista. So it's a good idea to make flashcards of these, and if you put them in your Pokédex right away, then it'll be much easier for you to figure out what the kingdom is. Okay. I wanted to spend, we're at 25 minutes. That gives me 5 minutes to talk about your stump speeches. So now if you don't know what a stump speech is, I'm going to explain to you in just a second. Stop this share. Share my screen. Where are you? Here we go. Okay. You guys are going to be assigned a particular, no, just kidding. You're gonna have to select, a group of organisms to make a stump speech about. A stump speech is named that because back in the day before television, somebody who wanted to make a speech would stand on a tree stump and say, hey, yay, I'm here to make a speech. And they'd say something. So you guys are going to do the same, except you don't have a stump. You're just going to do it and record it online. The stump speech should take a minute. It's really easy. All right. Now, what are the expectations of this stump speech? Number one, you guys are going to make some kind of flyer. Once you've selected the organism that you wanted to do, let me just pull up this so you know what organisms they are. Shall we? Okay, I'll show you the organisms in a second. You're going to make a little flyer that explains why a specific organism or phyla are in need of conservation. So, for instance, if you get Animalia, which is the easiest one. Well, animals are split up into 6 other phyla, but if you get a certain kind of animal and you choose a tiger, which is a part of phylum Chordata, then you can make a stump speech about trying to conserve tigers. So that's what your speech is about. Everybody, we have to conserve tigers. The most convincing speech that I deem most convincing will get extra credit on their practicum, which we haven't talked about yet. Okay. We're going to talk about the practicum this week on Zoom. Okay, so the flyer must include accurate information regarding the phyla characteristics. The value of each characteristics are explained in the flyer. And then the flyer includes 5 different colors, drawings of organisms from the phyla, and a rallying cry to save specific phyla. Save the bears, save the bears, save the crabs, save the crabs. That's an example of a rallying cry. Okay, your stump speech should only go maximum 5 minutes. It's not going to take you that long, I think. You're going to introduce yourself, the background of the endangered phyla. Some of your phyla are not going to be endangered, so you have to make up a scenario where they are endangered. Okay, what kind of conservation efforts are currently in place and why we should save that particular phyla? So that's your stump speech. This is going to be out of 30 points. It's going to go into your practical grade. I'm going to put this PSA rubric online so y'all can read it in your own time, but I wanted to show you what the phyla are. Okay, some of you will get Bryophyta, Phyllocynophyta, Coniferophyta, Angiospermophyta, and Ginkgophyta. These are the plants. Plants are in need of conservation just like animals, ha ha ha. Animal phyla, Porifera, Cnidaria, Platyhelminths, Mollusca, Annelida, and Arthropoda. And then phylum Chordata is split into further organisms, so bony fish, amphibians, reptiles, birds, and mammals. Most of you guys are going to cling for mammals right away, and we're doing a first come, first serve basis. So I'm going to post this, and whichever person sees it first will choose whatever organism they want. I'll make a discussion thread. They will say, well, I want this, and then no one can go back and choose that. Okay, we don't want any repeats. So actually there are 16 of you. That means 16, there's 5 plus 6, that's 11. 11 plus 5 is 16, there you go. So it'll be 1 per student. Okay. I think that's all I have to say about the stump speeches. Again, they are due on Wednesday, 11:59. And I thought about delaying it a little bit, but I decided that we're just gonna move forward. It shouldn't take you that long to just look some things up on your organisms. Actually, let me. Yeah, so over here, what you see is that I have some guiding characteristics that can really help you. So for instance, if you get porifera, you have to look up, well, does porifera have a mouth or an anus, both or none? Is the porifera symmetrical? In what way is it symmetrical? Is there a skeleton? Does porifera have some kind of external recognition features? And then you draw the organism down there. Once everyone has created their stump speeches through Zoom and have posted it on the discussion board, then everyone's going to watch the videos and then take some notes. So, okay, we're at 31 minutes. I think I've explained it. If you still have questions about it, please feel free to message me. I will help you. Mr. Din from Koreatown, checking out. Bye.